Hello, let's start modern robotics class. Uh, as I already announced, we will have midterm exam in the next week. Okay. Today is Saturday, 17th. So today's class will be seminar class. So because we already finished our chapter 3 and we will have exam at 8th week about the contents of chapter 3. I'm briefly have some introductory class using seminar. So in in this class, I will introduce our my lab about I will introduce about my lab. So DRCL. My lab name is DRCL, Dynamic Robot Control Lab. So I will tell you what kind of things we do and what kind of robot we developed and what is our interest. So about midterm exam, you can see the announcement in here. So I already uploaded the solution of chapter 3 exercise problem. So using this file, you can study yourself. So actually, the exercise problem in the modern robotics textbook is quite difficult without any instruction. So I just share the solution about chapter 3. So don't share this solution on public internet because uh, it has quite if you share this solution in public internet, it is very uh, big big problem. So I set the password on this document. So don't share this password. Okay. Uh, our midterm exam will be held next week. So schedule is, schedule is on the Friday, 3 p.m. Nowadays the corona virus is severe. So I worry I'm worried about that, but uh, I hope the next week the coronavirus is a little bit weaker than this week. So if the coronavirus is too severe, maybe we can postpone the exam on the next week. But until then, we will proceed our uh, schedule. According to our schedule, we will have the midterm exam on Friday this day. And, but if the corona is severe, I will announce about the changing of the schedule or something. Okay. Let's start seminar 1. Actually, this seminar material is about my previous work. So some contents is main contents is about my previous work, and some other contents is about open source robotics. Actually, when I came Yongji University, I am very interested on the open source. So nowadays, many people open their source code, so we can share the very useful contents, and we can study using that, and also we can create other contents using based on the shared source. So it is very powerful. It will be very powerful to use how to use the open source code, or if you know how to find what you want, can be your very powerful ability. So uh, before before saying about that, I will introduce my previous work. Uh, I graduated KAIST. Um, you may know the KAIST, Korea Advanced Institute of Technology. So I worked on the Hugo Lab. So Hugo Lab is very famous, one of the famous lab in Korea, maybe very famous in the world. And you might know this robot, Hugo. So I participated the development of Hugo, and my own created robot is this kind of Segway type robot. So I created the personal mobility like this, and also I developed this kind of uh, delivery robot. So this robot can deliver some delicate object on here without falling that. So in this figure, you can see the water bottle on here, and it can deliver very fast speed. And this one is stage for concert. So this is very big concert, and in here there is moving stage. There was moving stage and moving crane. I studied about how to control this kind of big system. So mm, this one is a TV news. My robot was uh, shown in the TV news. So as you can see, it has high speed of ability and can deliver very sophisticated object. And the middle mechanism, middle manipulator, control to balance the object of the top position. This is myself about 10 years ago, maybe 10? Yeah, 10 years ago. And this robot is transformable, so it can move in a 4-wheel, and also it can transform in a 2-wheel mode, and it can balance itself. He is my advisor, Juno O, Professor Juno O. Uh, Now he is retired, but he created his own company. So he managing the company named Rainbow Robotics. You can see, as you can see in this video, it has very high speed. You can see the skid mark on the ground. This skid mark is made by my robot, so it is very dirty. And the manipulator is very smooth and compliant. using my one finger, I can uh, defeat the muscle man, and I can control using the handle of the manipulator. And this is the second version with the more new hardware. And finally, when I graduate the school, I made this kind of cased version of Hugo Q. And the name of this robot is Hugo Q. And I made it, and I made three Hugo Q, and one, two of them is in my lab now in Yangji University. So actually, I bring back the robot from the Hugo lab uh, to for the future work. So I still studying about uh, the robot. So I am making this robot to deliver some food. So that is my one of the research topic. Yeah, this video shows two Hugo Q is working together. So when it goes circle path, should it should move the upper part to maintain the balance of the object. So my research goal was to maintain the object not falling down. Okay. When I was in the Hugo lab, that was the 10 years ago. In that time, there's not many open source code or open source hardware. So all this kind of hardware was developed in our lab, and this is the very important property of our lab. So we did not share about this one, and only in our lab we shared our property. So at the time, there is no the kind of open source uh, environment. So and uh, actually it was closed system. So all the intellectual property is was secured, and we 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 was not willing to share our intellectual property. But but maybe with the advance of smartphone, the sharing culture become very popular. And also in the computer science area, they shared their source code very often. And actually, the open source uh, open source phenomenon phenomenon was happened in the computer science. So nowadays, it is very common, and it is very uh, easy to find open source CAD or open source uh, software and open source code and open source hardware design. It is very easy to find, but at the time it is very difficult. So all these small things is very important technology, and uh, without it without it we cannot make this kind of robot. We couldn't. But when I uh, when I after I graduated, when I go Naval Labs, you may know the Naver, one of the famous portal site in the Korea, in Korea. So in Naver, they make the robotics lab named uh, Naval Labs. I worked on here, worked on there. When I uh, when I go this company first, actually this is software company, so there is no hardware background. So if I enter the Hyundai or LG, something like that, then I can I can maybe I can use the previous work actually done in that company, but in NeighborX, it was a software company, so there is no hardware background. So we have to build our own solution, or we should buy some solution from outside. So I searched very much about what should we use for motor control, or what motor we should use, or where can I build this kind of uh, robot, or where what kind of software we use. So during the process, I I figured it out. Uh, this kind of lab property uh, is already old-fashioned. After from when the 2016, when I searched the open source community, I figured it out. This kind of technology already old things, and many open sourced hardware or software is very advanced, already advanced and very useful. So I started use open source hardware and software. So using that, I participated to make robot and also last mile mobility. And actually, I this robot is the first product uh, when I was in the Naval Labs. So it is very meaningful robot. And when we make the robot, we made the Mechanom platform. I worked on that, and I made the personal last mile mobility named SMG, Sports Mobility here. So there is four wheel driving, and there is some tilting platform. So with this tilting, we can balance ourselves. And this is the computed token method based mechanism hill control. And we also made the MBDX. This is lightweighted robot arm. And this is power assistant card. And as you can see, this guy is me. Uh, I actually, when we preparing this video, we found some beautiful girl, uh, very famous beautiful girl to ride this kind of skateboard. Uh, she was one of the YouTuber, but the traditional four-wheel skateboard is not motorized. So that is passive skateboard. So that is very different with the active type electric skateboard. So she didn't ride at the first time, and she falling out of the platform. So it is very hard to uh, take a video. So that actor is myself, and that hardware was in our company, previous company, and I don't know, it's still there. But when I when I quit when I quit the naval labs, it was there. So it is past the 2 years. Well, about I don't know whether this robot is still there or not. And he is the he is the chief of neighbor. So his name is Yi He Jin. So he is the number one of the neighbor, and he rided my robot. And actually, he is very good at riding. So there's very good experience. Inside of the SMG is something like this. This is the battery pack. So one of the pack is here and the other part is here. And this battery pack is also self-made. This is the motor controller, motor controller, motor controller, controller, motor controller, and battery management system. So all the things is customized. Uh, yeah, it was very funny. It was very fun to develop this kind of robot. Yeah. And also this kind of robot, that robot was uh, trying to make some autonomous system. Actually, this one is steel ball, and steel ball is moving on the ground. But if the stage is not controlled well, the steel ball cannot maintain its position. So this example is no motion control. But if we using LQR based motion planning, we can stabilize a little bit more, but still it is having some instability. But if we add MPC based motion control, it is very well stabilized. There is no MPC control. I don't know why. Actually, you can find the video. You can find a video on the on the internet, maybe. This is my lab YouTube. Uh, yeah, this one. PID, LQR. This is MPC based motion control. Uh, in the more higher speed, the steel ball is very well maintained. So in the moving platform, uh, this object should stabilize with a very active control. And this kind of things is done in our lab. Okay. So we are still studying about this technique. So we are making some high speed delivering robot. So this is the uh, one of the final product image. So this is our final year of this project, and this is the motor controller I'm working on. Actually, the motor controller is the most basic component on the robot. If you use the electric motor to make some actuator on the robot, the motor controller board is one of the very important thing, because depend on the motor controller, the upper part component is changed. So if you're using step motor, if you're using DC motor, depend on the motor type, the the robot actuation is different. And also, if you're using BLDC motor, you can you should change your motor driver for the BLDC. And depending on the motor controller unit, so you should check the communication type and control bandwidth, and also what kind of PC will you use. So these all the things is depend on the motor controller. So selection of the motor controller is very important. So uh, I I used the BESC. The BESC is the open source motor controller. Actually, some Swedish guy made it. So Benjamin Beder, he made the BESC, and it is one of the very famous open source motor controller. So it is also used on the MIT race car. So actually, this BESC is specialized on the field-based system. But in my case, I want to use this BESC on the robotics system. So I designed my own PCB and made the stackable motor controller shield. So if you stack on the Arduino, you can use the main controller. The Arduino can be used the main controller. So by using Arduino, you can command the motor control. And in my BESC version, we can use very precise position control scheme. And also we can use loss-based robot operating system based control. The main communication method is USB, and also you can use CAN to control the robot. So this kind of things is about the controller, but I will show you some more detailed information. Actually, this robot controller is selling on the internet. So if you choose the neighbor smart store here, can buy the motor controller unit. So this one is just single motor controller, and this one is motor controller with motor actuator. So this is the motor reduction gear and with motor controller. So if you buy this one, you can solve the actuation system. And if you just design the link, and if you connect the joint with the link, you can make your own, some kind. You can make your own robot, like MIT Mini Cheetah, like robot. And this robot, this actually is very good and very powerful. And this is my motor controller. So this is the video 3D printed actuator. So in here, motor controller here on the back side, and there is motor drum motor here, and here there is 3D printed gear, and there is link. So if you want to build some kind of robot, you should uh, consider what kind of actuator you use, and this this one can be one of the candidate. Uh, about our project, I uploaded our content on the hackaday.io, hackaday.io. Uh, this site is one of the famous sites uh, to share some information about hardware development. So in this site, there are many projects, especially hardware project and also software project. So someone made this kind of things and upload what did he do. So you can check this site for studying, or if you want to make your own robot, you can check what kind of things are already made it, or other people how to make the robot. So the kind of things you can find in this site. So in my case, I uploaded my planetary gear actuator and the motor controller unit and the cycloid gear-based actuator. This kind of things was uploaded. And also we made some 6 degree of freedom actuator using our own made in 3D printed actuator. So I'm testing about this one, and maybe in this year I will show the result of the actuation. So what is open source? So I introduced about the hackaday.io. If you want to find some software code, you can check the GitHub. You may already know the GitHub because I uploaded my modern robotics, Simulating modern robotics library is uploaded on the GitHub. So you may already know GitHub. And about the hardware, you can check hackaday.io and hextot.io. And you might know the Thingiverse. Thingiverse is one of the famous 3D printing library, open source. And also GrabCAD. GrabCAD is one of the famous CAD library sharing site. And about the ROS, robot operating system, you can check the construct sim. It is one of the important famous ROS site. So if you want to learn the ROS, this is one of the solution. you might if you uh, you might already know uh, in the China they selling MIT mini cheetah motor. Yeah, this is the MIT mini cheetah actuator. So as you can see, they copied the design, the motor, and they are selling. And the quality is very good actually. So if you assemble this one, you can make this kind of MIT mini cheetah. Yeah. Actually, that is almost 2 years ago. So yeah, this becomes very common things. Because I think that is the power of open source. So one of the bright thing of open source is you can easily make this kind of robot. Yeah, but the dark side of the open source is common too common this kind of robot. Yeah, the technology uh, barrier is very shortened, very lower because of this kind of sharing technology. So this is the one of the actuator. And yeah, this is very good and very cheap. Let's see this one, RMD X6. So this one has, yeah, they also made it controller, and it seems very good. Uh, so in here, nominal current is 3.8 and 180 watt. Nominal torque is 5 Newton meter. 5 Newton meter. Torque constant is 1.5 Newton meter per ampere. This one is very important thing, the torque constant. Actually, in these days, motor gear ratio is the small gear ratio is popular. So in the past, we usually used very high gear ratio for the precise control. But in these days, we usually focus on the torque control. So uh, for the for the exact for the torque control, the lower ratio is better for torque control. So this one using this one using torque motor. So it seems very good. Maybe we should maybe we should test this motor. What is this? This one is, it seems like this one is also a motor, servo motor. Yeah, it seems quite good. Okay, so this one is the constant is 1.0.208. Yeah, this one is quite lower torque. So okay, so actually the motor controller is very open because there are many this kind of open source motor controller, and uh, in the MIT mini and in the MIT Mini Cheetah, they also opened their firmware about the motor controller. So this is one of the motor control firmware. So this, because this one is shared on the internet, the China can make very easily the motor controller. So yeah, but actually mm, this one also good solution. Yeah, this is my solution, and this is for good motor controller. Okay, so I want to know. I want to announce one of the license issue. When you use open source, there are um, most famous open source type. One of them is GPL3, and the other one is MIT or BSD license. So if you see these kind of things, you can figure you should figure it out. What is that? So actually, the GPL license, GPL3 or GPL something license, if you use open source, if you use open source, you should you should you should also open your code. So if you download some open source code and you change something and you created other things using based on the open source, then you should also open yourself, open your course. Also, you should open. So that is GPL3 license. But in case of MIT or BSD license, there is no need to open your code. So if you download some open source, then you can use that, and there is no obligation to reopen your own code. So this MIT and BSD license is mm, more freely used, and this one is some constraint to reopen your own source. So it is good to know about this one. Okay, this one is finished. So let's pause a little bit and I will continue again.